This week we will study a branch of mathematics called trigonometry. We're just going to scratch the surface. This is something you can study for a whole semester. We're going to spend a week on it, and I would like you to understand what the word means. I want you to notice we have three pieces here. We have trigon and metry, and I want you to know that gon, of course, means sides. We have pentagons, we have hexagons, and if you'll be a little creative, you can imagine that we could have things called trigons, things that have three sides. Of course, what we actually call those is not a trigon. We call these triangles. And we're going to study specifically today, this week, we're going to specifically study right triangles. So what does trigonometry mean? Triangles. We should be able to clean that up, right? I think I can spell triangle. Well, this is the study of things that have three sides. And the metry means measure, just like geometry, which means earth measure. So we're studying side lengths and angle lengths of right triangles. Now, would you believe that if I have a triangle that has a right angle and has a side measure of 1 for its short leg and a side measure of 2 for its long leg, it doesn't matter how big or small that triangle is. That could be 1 meter on one side and 2 meters on another side. It could be 1 nanometer on one side and 2 nanometers on the other. It could be light years. It could be anything at all. What we find is that as long as you have a triangle that has a side length of 1 and a hypotenuse of 2, that angle right there will always be the same, regardless of the size of the triangle. And in this case, that angle will be 30 degrees. We've studied that already. But if I told you that this is 1.1 and that was 2, we'd have a slightly different angle over here. That angle would never change regardless of the size of the triangle. As long as you had a 1 unit or a 1.1 unit and a 2 unit, that angle would always be the same. And so we're going to study special characteristics of right triangles. And I'm going to tell you that a right triangle, of course, has one right angle, and it has two acute angles. And it has one hypotenuse, and it has 2 legs. And the hypotenuse, as always, is opposite the right angle. Okay, now let's talk about some ratios here. Let's pretend I'm down here. I'm going to sit, I'm going to start a new triangle. I'm going to sit right here in this angle, and I'm going to name that angle theta. We're going to use this symbol theta instead of x during our exploration of trigonometry. And I'm going to tell you that the opposite leg, I'll call it op leg, divided by the hypotenuse is 1 ratio, op over hyp. And the adjacent leg, in other words, the leg that's next to the angle, not the angle that's opposite, not the side that's opposite the angle, the leg that's next to the angle divided by the hypotenuse is another important ratio that we're going to study. And finally, the last ratio we're going to study is the opposite leg over the adjacent leg. So these three ratios have a special name each. I'm going to call the first one the sine of theta. That ratio is called the sine of theta. The next one is called the cosine of theta. The last one is called the tangent of theta. And we never write these out like this. I've written those out like this for your amusement. What we will actually write is S-I-N, still pronounced sine, not sin or sine. Sine of theta. Cosine of theta. I will key your car if I hear you say cos. And tangent of theta. If you say tan, I'll survive. I won't key your car. So, but I would prefer that you say tangent. It's pronounced sine, cosine, and tangent. I know this is messy. I'm going to hand you over to Saul Kahn in a little bit. His work will also be messy. I'm going to clean it up a little bit. I want you to notice some things in here. I want you to notice the letter S and the O and the H. I want you to notice the letter C and the letter A and the letter H. And I want you to notice the letter T and the letter O and the letter A. We have a way to remember those three ratios using their initials like that. We say, get ready, here it comes. You're going to hear me say this 3,000 times. I hope you're going to memorize it too. We say, so, notice I'm intentionally capitalizing the first one. They're all capitalized. I'm making a bigger capital there. Ka, toa. This is our little mnemonic that we use for memorizing what you see up here. Okay? SOHCAHTOA. You're going to hear me sing it. You're going to hear me say it. SOHCAHTOA. What is SOHCAHTOA? SOHCAHTOA is a short, easily memorable word for memorizing those three facts. What are those three facts? Those three facts are the sine of theta is equal to the opposite leg over the hypotenuse. The cosine of theta is equal to the adjacent leg over the hypotenuse, and the tangent of theta is equal to the opposite leg over the adjacent leg. Okay, and I'm going to show you how we use those. Okay, so I have a triangle right here, and it has a right angle, and it has an acute angle of 31 degrees. And I'm going to tell you that if I take, I don't care how long these are, miles, light years, whatever, if I take the opposite leg and the adjacent leg and I make a ratio out of those, which is called the tangent of 31 degrees, what I will do is I will go and I will look that up using a calculator, and I will find out that that is equal to, I believe, 24. Hold on, making a mistake, getting out my calculator. Watch me do this really quick. What is the tangent of 31 degrees?
The answer is approximately 0.600861.
Alright, so here we go. We'll unwind that just a little bit. She told me 0.600866061. And her result in my iPhone goes on for about 25 digits. That number does go on forever. It is an irrational number. In other words, you can't represent this as a fraction that repeats or terminates. But we're not going to use it as an irrational number. We're going to use it, its approximation. So this is approximately equal to that. And we're going to most likely round that. Your instructions when you do work like this will be round to 3 decimal places. Okay, and what does that look like? Well, in this case, 0.601. I'm going to stop the video here. We have a lot of work to do, and we're going to use all kinds of videos to do this, and I think this is a good place to stop this one. Thank you.